Hello everybody, my name is Dave. I hope you guys are all doing well. Today I want to talk about design and specifically some of the things that I think about when I build these campers, and most importantly what I've learned after building 6 so far. What you guys see here is about the 50% finished Camper 6.0, my 6th camper. If you're brand new here and you just somehow randomly stumbled across this video, my name is Dave, and I, as a hobby, build little wooden campers primarily in my garage. Alright guys, but let's go ahead and get started, and we're going to talk about some of the design features and what I've learned over the past couple campers. If I had a vision statement regarding the goals that I have when I build these campers, it would be to build a camper that has zero effect on the drivability of the host vehicle or the pickup truck that it's mounted to, but still provides all of the reasonable amenities and comforts that I personally am looking for. And what I mean by that is this, both personally and through talking to so many others, one of the things that wrecks a camper experience or a trailer experience or some other RV experience is the problems and the hassles that come along with putting a camper on a truck and it dramatically reducing its gas mileage or performance, towing a big trailer, having the same effect on a vehicle, the inability to, get into gas stations or park in normal parking lots. All of these hassles many people give up for the comfort of a larger camper. And I understand that, and I'm not passing a value judgment, but for me, in an ideal world, is to put a camper on a truck and essentially be able to drive it and forget the camper's there. Now, obviously that's not entirely a realistic goal in the long term, considering, the amount of additional space these displace and so forth. But for every camper I've built, I've always tried to step closer to that goal, and I've learned a few things along the way. So in terms of, for me, there's really 3 factors that I think adversely affect the drivability of a vehicle in terms of truck campers, and those are the 3 factors that I definitely target when I design these. Number 1 is weight, and I think that's a pretty self-evident one. Obviously, the lighter something is, typically the better it's going to be. Now, one thing to consider though is, like many things in the world, the amount of the benefit you get from a reduction of weight probably has an exponential curve, meaning that if you can drop weight a lot, you're going to get a lot of benefit, but at some point, at some juncture point, you could remove a lot more weight and the amount of benefit that you get would actually degrade. My point to all that is the final sum benefit may not just be to reduce all the possible weight that you can, but get down to some set point. For me, it seems as though, and I'm speaking of dry weight, I'm not speaking of loaded weight, that if you can get the camper somewhere in the 700 to 800 pound range, 50 pounds, 100 pounds, one way or the other doesn't make a lot of difference. But that's kind of that set goal. It's just sub 1,000. Essentially, by the time you put all your stuff in it, if you can get that camper to where it's about 1,000 pounds or less, that's ideal. If you could save 50 pounds off that, once you get to that critical point, I don't see the benefits continue to climb. With all that being said, I'm not dissuading someone from trying to reduce a possible amount of weight, but I am also trying to position a realistic perspective on that. Number 2 is it's important not just to reduce the weight of the camper, but to distribute the weight of the camper in a meaningful way. And what I mean by that is this: if you have a 800-pound camper, but most of the weight sits high in the camper, that's going to have a bigger impact than an 800-pound camper with all the same equipment, but the equipment set lower in the camper and lowers the center of gravity. And a lot of that comes down to the effects on handling of a pickup truck when you turn corners and so forth like that. And I've definitely noticed if you have a lot of weight high, you can definitely notice that a lot. If you do a really good job keeping the weight low in the camper, sometimes you could almost virtually turn the truck and maneuver it, and that initial additional inertia of the weight in there doesn't affect it nearly as much as you would think it would be. And then the final thing is aerodynamics. Now, I've talked to you guys before about aerodynamics. I just basically know the very basics. that gives some broad principles that guide how I build things, but I fully acknowledge that the study of aerodynamics is very complex. There's many small factors that can have big impacts, and in an ideal scenario, using a wind tunnel or other advanced testing techniques would be the real way to fine-tune and pinpoint all the small nuances. Is that obviously that's outside the realm of me and my circumstance, but so keep that in mind. I'm going to talk about some aerodynamics. I'm making some assumptions that may be incorrect or maybe not partially correct or not fully correct, and also I'm just talking about the general larger principles, acknowledging the fact that there's perhaps small design nuances that I could do that would have bigger effects. I'm just not aware of them based on my circumstance. So, but let's start off with weight and a couple factors of how I'm reducing weight on 6.0 and how I've done it in past campers. Now, for 6.0, this camper is really turning out to be pretty light. Now, for those who've not watched my channel before, I made the camper just previous to this. I used a slightly different building technique where the outside was actually covered by 1/4-inch plywood and a waterproof finish on top of that. This camper is actually made by the use of cedar planks. So hopefully it picks up in the resolution of this video here, but all of these are individual cedar planks that are attached to the camper. Now, some of my preliminary tests between the 1/4-inch plywood method and this one is that there's about a 20% or up to a 20% weight difference, meaning that the cedar planking on the sides is perhaps up to 20% heavier. With all of that being said, though, the cedar plank side campers still have come in very light, and for the stylistic looks that I was going for in this case, decided to go with the cedar planks. I think they're still a wonderful option and provide a very unique look, which you don't see everywhere. But I did do a couple other little lessons I learned from Camper 5.0 and expanded some of those lessons in here that I think will make up for the additional weight difference of using the cedar siding. So as we've discussed in previous videos on 6.0, all of the horizontal surfaces of the tub I actually made using, I'll call it a composite building technique, and essentially built a form of a structural insulated panel that made the floor and the wings or the horizontal portions that would extend over the bed rail. I did the composite of some XPS insulation and 1/4-inch plywood on the top and bottom, which was a departure from where typically I would use 2 layers of 1/2-inch ply. The short sum of all of that is that definitely reduced perhaps maybe up to 50 or 60 pounds in weight in the tub, which is a pretty notable weight reduction. In the roof, I also actually used that 1/4-inch ply, just like I did in 5.0, and that will be reinforced with XPS insulation on the inside and a waterproof coating. It's not particularly relevant to this video, but has already been applied on the roof, and that's essentially done. I'll talk about that at some other later time. But the combination of the two of those are definitely techniques that I've utilized in Camper 6.0 that I have not utilized in other cedar side campers to help reduce weight. So the net benefit is, I think, overall this camper should probably be coming in about where 5.0 did, even though it used a different skinning technique. Now this camper is dimensionally a little bit larger, most notably in the size of the cab, the height and the length of the cab over section. So with all that being said, I will expect this camper being pretty conservative, probably in the 800-pound range, which is still pretty light. And like we talked about before, when you get in those margins, if you drop another 50 pounds or so, it may not make as big of an impact as, you know, dropping it from 1,500 pounds down to here. So let's talk about weight distribution. Okay guys, so this is the back of the camper right here, and as I've done in pretty much every camper I've built minus 1.0, is there will be an AC unit that sits in this area. Now, putting a heavy object, which AC units can range in, you know, the 40 pounds or so they're somewhat heavy, in an area right here is by no means ideal for 2 specific reasons. One is it sits relatively high in the camper, and 2 is it's sitting behind the rear wheels. And that kind of highlights, when it comes to weight distribution, the 2 factors that you're really looking for, and that is to keep the weight low and to keep the weight centered over the rear axle of the pickup truck, which in this camper would be approximately in the position where the side window is, roughly speaking, or in front of that rear axle. But in coming to a compromise between amenities and other things, this is the one big compromise that I had to do, and that was to put the AC unit in the back and to put it high. Now, lessons I had learned on other campers with the AC unit is, presumably because cold air sinks and is denser and sinks down in the lower portions of the camper, to have the AC work as effective as it possibly can, I had to have it raised up to a higher level in the camper. And then number two, for it being on the back, just came down to the practicalities of an easy way to vent it. But other things that I've done on 6.0 and other campers that I am trying to do to keep that center of gravity low and keep that weight on top of or in front of that rear axle is water as number one. Most of my campers have had removable water containers that have a capacity of about 7 gallons. So total, I would carry about 3 of those, so 21 gallons. Water is about, I think it's 8.2 gallons or 8.2 pounds per gallon or thereabout. So you're talking, that's a couple hundred pounds right there if you carry 21 gallons in here. Now, in some of the previous campers, I would actually sit them at tub height, or essentially the height of the cab of the pickup truck on the inside, when I would put them underneath the counter. And it wasn't a big deal, but on 4.0, 5.0, and then now 6.0, I actually moved the water to floor level and forward of the rear axle, and I did notice that that the campers, though it wasn't bad in the other configuration, definitely felt a little less top heavy. So that was one change I could do. On 5.0, I was actually able to put the fridge where it slides on at floor level underneath a portion on the inside of the camper. Now for 6.0, I will not be able to do that, and I will put the fridge up on that tub level or the cab level of the pickup truck. But instead of having it toward the back, I will shift it all the way toward the front. So I think the negative of having that 50 or so pounds a little bit higher is probably going to be undetectable. A couple of the things that keep the porta potty low. My long-winded point to this is for 6.0 and for other campers that you build, or for other people who might be considering making their own, is think very hard, not in just reducing the weight, but actually moving it low and forward. One of the things I'm going to do in 6.0 is I'm going to actually move the battery and all those electronic components and put them more toward the front of the camper also, which I think should help with some of that weight distribution. Let's talk about aerodynamics. All right, guys, we're going to take a little visual tour here. One of my favorite things about Camper 6.0 here is the shape and design of it. Now, this doesn't just have an aesthetic reason, but more importantly, it has an aerodynamic reason. As I talked about in the beginning, I'm trying to build these campers to where, in an ideal world, I could put it on the truck and the truck would not be affected. Again, that may not be realistic in the long term, but that is that vision. That's that long-term goal. So number one, what I did on here, which was very new and I think interesting and unusual, is I actually built the cab over narrower and with a smaller profile. Now, I'll talk about the genesis of that, but the larger and broader idea in terms of aerodynamics is reducing that front profile. Basically, in my mind, the amount of surface area of a camper that sticks out beyond the truck, which the truck's already going to displace that air, the less surface area that you can have extending beyond that, the better. And the surface area that you do have, you should contour it with so the actual air hitting that surface area is extended and graduated over a larger distance. So for example, in the front here, by tilting forward that the front cap there of the cab over, ideally, hopefully, it will help spread out the pressure of that air and, you know, essentially make it more streamlined, as you would typically know. Up there at the top, where are we at here? Where we go? There we go. You guys can see the curved profile right there. And one thing I've learned from other campers and just kind of looking at other aerodynamic things like planes is in transition points, I think a sloping curve is far better than an angle. So putting in that curve right there was quite a bit of extra work, but I think it will work out in the end. Now, something I did down here that was very interesting and kind of defines how I created a smaller profile with the cab over is down here. So in this section, this would be where the cab of the truck would essentially sit. So this right here would slide in the bed of the truck. This back wall would be up by the back window of the truck. And then the cab of the truck would essentially be underneath this space here. Now, one thing that you typically see in a lot of campers is this angle right here sticks out quite a bit from the side of the pickup of the cab of the pickup truck, which creates this blunted surface that's going to catch a lot of wind. So what I did is this is actually set, this beam right here is actually set at an inward angle of about, what was that one, 7 degrees, I believe it was, off center. And this, it's hard to see right here, but this actually angles in the tub portion. So what the result is, based on my measurements, is when the cab of the pickup truck will sit here, this will only extend about 2 inches on the outside, and then that edge right there has a very, it's a little bit angular, but it's quite rounded, and hopefully that should create less surface area that hits right there on the sides of the truck. And then, as you guys can see, where are we at here? This graduates backwards, so it's getting wider at this point, and it's narrow at this point. And then as it goes up, this transition surface becomes larger and larger the farther you go up along the wall of the camper there. So what that means is that the front of the camper is actually a couple inches less narrower, particularly at the top where the impact is most noticeable, than it is at the very front. And the hope is that this would create enough of a graduated surface to kind of minimize some of that friction, wind resistance when the truck is, when the camper is moving forward. Now that right there took a lot of additional work, and hopefully it will have a big benefit. But you can also see what it did is it is the top of, it's a little hard to see in here, but the top of the cab over section is actually narrower than the bottom because that angle continues to the cab over surface. Now that angle doesn't stop though. Now this is a lot more subtler and maybe not noticeable in the video, but this beam right here, or I'm sorry, this column right here is also angled back by only about 2 degrees. So this whole back wall back here is actually pushed in a little bit at the top. And again, that comes down to reducing surface area and that compromise between amenities, comfort, and trying to reduce other factors such as aerodynamics in a vehicle. Now, what I've found from many of my other camper builds is that the top being a little bit narrow at the top doesn't have a huge impact on the space inside the camper within certain reason. This small inward angle on this one certainly won't have any noticeable impact. In fact, it might even add some visual appeal on the inside, creating a little bit more interest. But that's not where these all stop. So from this point right here, this is the widest point east to west of the main body of the camper. This back part actually tapers in. Now it's very hard to see, but what that amounts to is the width of the rear of the camper is several inches narrower than it is at the wider point. And again, that has a big role in aerodynamics. And the reasoning is this. So we talked about the first principle of trying to reduce friction aerodynamics by reducing the overall surface area and profile of the object. And in areas where you can't, having a smooth transition and using curves at those transition points if possible. But there's another form of aerodynamics, and that other form of aerodynamics is called negative drag. And what that is it's the turbulent air that is produced at the rear of the camper that actually creates a drag effect on the camper. And again, it comes down to surface area. So what I tried to do here was reduce the amount of surface area of this rear area. The most aerodynamic object would have the rear would come at a point. Obviously, that's not an option here for a variety of reasons. But reducing that surface area, I hope, will help reduce some of that rear aerodynamic drag. But also other factors like having this back end curve in slightly to the rear, not only does it reduce the overall surface area in the rear, but creates a transitioned angled approach for that air that I hopefully can sip around the back and smooth out some of that turbulence and other drag. I hope that makes sense, guys. Now, the slight inward angle of the top of the body is hard to detect, but if you look at this wall right here, you can see a slight difference where this column here is actually narrower at the top than it is at the bottom. Now, the final two changes I did was the rear has quite a notable slope from its highest point, which would be right here, and it slopes down to the rear. And the rationale behind that is, again, the very same things of reducing the negative aerodynamic drag in the back, reducing the overall surface area, but also hopefully that air that comes over the top will cling to the top and come back down into fill that void of the negative aerodynamic drag. The final set of angles and curves I did is at the bottom, down right there. Okay, that is a 7-degree off-center transition outward before it hits the wall there, and then that contour follows the angle north to south of the side wall. Now, some of that is more cosmetic, I'll admit, but it also hopefully has some sort of aerodynamic effect by, again, reducing that overall frontal surface area. Like I said, in many ways I'm guessing on these aerodynamics. I don't think it's going to hurt anything at the worst case scenario, and at the best case scenario it may have very significant benefit impact or positive impacts. At a minimum, though, I think taking these different shapes and angles and dimensions into play are going to produce a very, very interesting camper that's really like nothing you've seen before. Thanks for watching. Share, like, subscribe, comment, etc.